This short video explains how to submit a Verilog or another HDL project to Tiny Tapeout. The website has some resources collected here under the Working with HDLs page. Let's take a look at the Verilog demo repository. The link is below. The repo is forked from the submission template. If we take a look at the info.yaml, the important thing is that the WACWI ID is set to 0, which tells the system we're doing an HDL design. Then you list all the source files separately. You must list all the required files or our build process will fail when we try to include your project. We also need to give the name of the top module. Your top module name should be unique and start with tt_um_. I suggest you include your GitHub username to make sure it's unique. You can see we've got all the 3 green lights here passing. The GDS and the docs are required to do a submission, and the test is strongly advised. If we go to the source, then we can see we've got the counter and the decoder Verilog files. Inside the counter, we've got the top module. The top module must have exactly these input and output ports. This is the interface between your code and Tiny Tapeout. You can't change their names or add or remove anything. Now let's talk a little bit about how you can test your design. I'm a fan of CocoaDB, so I have this makefile. I set my Verilog source here and include a top-level test bench. The test bench just instantiates a design and wires up the input and output ports. You should be able to reuse this with very little changes. All the testing actually happens in this Python file. I start a clock, do a reset, and then I count to 10 waiting for 1,000 clocks. That's how long it takes to count up to the next number on the 7-segment display. Then I assert that the segments that I'm getting out are matching the expected segments to be shown on the display. I can show that here on the command line. It created me a VCD file which I can load and inspect with GTK Wave. I can see there's the clock, the reset, and then the segments counting up in the order that I expect. We have a test GitHub action you can use, and this just installs the OSS CAD suite and runs the test. You can copy it from the Verilog demo repository. It's optional to have a test, but I do recommend it given the long waits that we'll have to receive our designs and the fact that we can't change things afterwards. It's also a good idea to do gate level verification, which is where we take the post-synthesis netlist and check that with the same test bench. Ask on the Discord if you want help adding it. So good luck and let me know how you get on. I'll see you in the Verilog and HDL channel of the Discord chat server.